I'm gonna start
Zero.
recording. Yeah, here.
Yes, yes, yes. Exactly. So the default tempo is 60 BPM, okay?
Exactly.
Okay, can we change it?
Yeah.
We can choose the tempo clock or something else.
Yeah, you have to change the tempo.
Clock.
Yeah, tempo clock here and go, for example.
Because I tried and what is it works now?
It should work, yeah.
Okay. Okay.
And I can make it like super fast if I want.
Yes. Yes, yes. What is why you write 300 slash 60? Why need the 60 per 60? It's why it is not necessary the 60.
Because okay, because actually tempo works with
Default 60.
yeah, well, no, the default is 1. And 1 corresponds to 60. So I make this division so I could be thinking in BPMs, but the actual division makes the number that so if I divide, it gets 5, right? So basically it's to you have to put a number that's an integer number that, well, it can be a float number, but yeah, if so the default, actually, for example, the default tempo is 1. So 1 will be 60 BPM. If I put 2, that will be
120.
Exactly. But that's pretty weird. For example, if I want a really weird number, because what happens if I want my tempo to be this 134? So if I divide this by 60, I know that this number will correspond.
Okay, I understand. Yes, it's the same. You need 2.
Yeah, that will be 134, right?
It's the same. Yes, yes.
Yeah, so I make the division to avoid thinking in these weird numbers and just think like the number I want divided by 60, because this 60 is like this 60 corresponds to 1, so it's the default. Yeah.
So I understand. So this number means 1 multiplied by 2.2333. No.
Exactly.
Yes, exactly.
Yeah, exactly, because this will be like 2 multiply the tempo by that number. Yeah. Exactly.
But that number, but
if you want to go,
it's easier to write 40 slash divide.
Yeah, because these are really weird numbers, right?
We understand the 40 from metronome.
Exactly. So we go through.
We understand it, yes.
Exactly. It's like easier to link it that way, but you can go put the. I can go and put like, I don't know, like something like this. But I'm not sure what this number corresponds to an actual tempo, right?
Yes. Okay.
It's just easier for me to think it that way, right?
Yes. Yes. Okay. That's all. Thank you.
Don't worry. I started recording just so the doubts are, also recorded, so everybody gets that because some of the students are gonna take this in the video. They told me in the chat, right? So anybody of the had any question about recording last class or whatever? Nope, we're good. No more, not many. Okay. So I'm gonna go through this patch and let's analyze some of the syntax we used last class. For example, we have this kick and this hi-hat. Because last class I just copied directly from other code and we use it without going to them, right? So this is the hi-hat. This is the kick. So hi-hat, we see here that the first signal is a ping noise. So remember that ping noise is just, it's the same idea of the white noise, but the ping noise actually has like the configuration to make the to make the perception of our hearing that we are hearing equal magnitude through the whole spectrum. The problem, and I said problem because that's problem in our audition, not with the actual physics of the white noise, is that we tend to perceive more amplitude towards the high pitched sounds. So we kind of perceive white noise as a high pitched, at least we perceive the high part of the white noise as more loud, as it has more amplitude. So we don't perceive them as equal power. So ping noise has decibel. So the decibels of the frequencies are getting low towards it goes to the high pitched part, to the high spectrum. So we perceive it as a continuous spectrum. So this is a ping noise is more near our idea of sound that has all the spectrum in equal magnitudes, basically. So I'm using it just as the source to get the part. And then I'm using the high pass filter and I'm filtering everything that's below 8,000 hertz, I mean. So I get only the high pitch part. Then I have a really small envelope because I want that sound. It's on action and I'm multiplying the sig by the envelope and an amplitude argument. I'm putting a really high amplitude because I'm actually only getting the high part of that already it's softened by the ping noise. So I'm giving it a really high multiplication and I'm using a panner. And that's basically all. And I get this, right? Works pretty well. The kick, it's a lot simpler. I have a sine wave at 60 hertz and a sine wave at 130 hertz. I have an envelope for each one. I have a really close envelope, really small envelope. As you can see, actually, this M1 doesn't have an attack. I just have a release because I want that ta, ta, tu, tu, tu. I just want the hit. I want a plain hit. And I'm applying that envelope to the high pitch part because usually kick in general drums are a little bit more high pitched when you hit them with a mallet. In the case of a kick with the pedal, and then they get a little bit lower because of the sound of the actual skin, you know, the membrane. So it's just two envelopes, one envelope for each part of the sound, and then they are just going in additive synthesis. So let's hear it. It's pretty simple, actually, that sound. It's not the best kick in the world, I know. We're gonna make a better kick. I think next class with with FM synthesis, but for now it was just to analyze these two sounds. So is there any question regarding something?
Yeah, just here, we went through that last week, but the done action, whether we put it in envelope 1 or envelope, just like, I mean, we can put it, you know, whatever envelope, it's gonna be the same, right?
It's gonna be the same. In this case, I just choose the larger envelope. this one, that last more, because if I change it
Mhm,
to the smaller one,
mhm.
that will activate the done action before the actual sound is ended, and it will cut it like this. I don't know if
Oh.
you know, if you notice that click,
Yeah.
because the other one was still running. So you always, yeah, tell me.
Yeah. No. So. Okay. So if we had like reverb, something like that, so something that goes for a long time, so that would cut the reverb as well, or that would.
Yeah, it will cut the river as well, and it will be a problem. What you
Yeah.
have to do in that, you have to make a different SINDEF that contains the river. I want to show you that now. Why not? Because it's a pretty common doubt. And how to manage this is pretty easy. I'm going to show you. Yeah. Wait me just 1 second.
Yeah, sure.
Sorry. I'm back. What I was, okay, yeah. So I'm just looking for a patch that has this example.
I know my sound is a bit funny, like sometimes you're cutting off and stuff. So is it only me, or you guys also hear Michelle sometimes cutting off? Or it's only me?
Yeah, please. Is that for everybody, or now I'm fluid?
Yeah, right now, like you're totally like going everywhere. So is it only me, guys, or it's?
I'm hearing fine also.
You're hearing fine?
Yep. Everything okay.
So maybe it's my headset. Okay.
Yeah, because my connection is cool.
Okay.
Also,
so maybe it's mine.
Yeah. Also, even though you're getting that, and my video is recording it in the correct way, but now you're hearing me okay or not that okay?
No, it's fine. It's not perfect. It's okay. Yeah. I try to log off and back in with my Bluetooth, but whatever.
Okay, sorry, I have to take a pill. I'm back in. So yeah. So here I have the same sound, the same snare sound. So this is the dry sound. And now here I'm adding the reverb. And look what happens with the reverb and the tone action. I don't know if you can hear that the reverb is being cut.
Yeah.
And that's with the tone action. So I'm gonna take again that. And here I have a SINDEF that I made exactly for the reverb. I don't know if you have shown you this, but these bars, basically it's the same as doing this R and the semicolon. So these are different syntaxes for arguments, this one. So you can use this one. So
Also.
in this, what?
Also.
Yeah, also using the bars is the same as putting R and the semicolon at the end.
Yes.
Okay.
This kind of alternative syntax are pretty common in SuperCollider. It's good to know them because maybe sometimes you will encounter some codes that has this, and at first it could be what, like That's crazy. It will be, could be weird if you don't know it. So in this case, I'm using, here I have the freebird and the pan, but my signal is this thing called in. So in is basically it's an inlet that reads a signal from a bus. In it says that read signals from audio and control buses respectively. In.R can access audio signals that were generated in the current calculation cycle by seeing nodes located early in the node tree. It does not read signals left on an audio bus from the previous calculation cycle. So basically, it's an inlet that will read wherever it's inside a bus. Actually, in the first argument of if in asks for a bus to read. So basically, it reads from a signal. So for that, you need to create a bus.
Oh, okay.
This is a representation of a bus on the server. The client-side representation, remember when this description says the client side refers to us, of an audio or control bus on the server, encapsulates all the OSC messages a bus can receive, manage allocation and deallocation of bus indices so that you don't need to worry about conflicts. The number of control buses, audio buses, and input and output buses is fixed and can be changed after the server has been booted. The reason it says that it encapsulates all the OSC messages is because the interpreter on the server communicates via OSC messages. You don't have to worry about that. This is just too good to know. So I just need the bus, and it just asks for at least, it will ask for the server. So I'm using S, so it will allocate in the actual server that we have. And I'm doing 2 channels because I want to be stereo. And I'm instantiating that with a global variable called just bus. So I run this.
Michelle,
Yeah, please don't.
bus means channel.
Yeah, it's a channel. It's like
It's a
a
channel.
track audio signal.
Yes.
Yeah, channel will be a good way to translate that, I think. I run my server, my river, and then I'm initializing my river, and I'm putting the bus, the argument bus that by default is in 0, but I'm putting it in this bus that I have. So now my river is activated. We can't hear it because not anything is going through that. But now I'm running my SYNDEF, this SYNDEF called Parola, that basically that's there in Spanish. And I'm putting the out, instead of sending the out by default to the 0, I'm sending the out to bus, to this bus. So I run this. And now we can hear the river. And anything that I send through that bus will be affected by this effect. Also, in this case, by the panner. And if I add here more effects and more effects, everything will be affected by that. And I can make as much SYNDEFs of effects as I want and send them to different buses. So I can send bus number 1 has an effect and a delay and a river. Bus number 2 has a different river. Bus number 3 has a compressor. Bus number 4 has, I don't know, a bandpass filter. And I can say, okay, I need my chords to go to the bandpass filter, and my hi-hats to the first river, and my kick to the second river, and so on. So that will be more similar to work with the way, I don't know, Ableton Live or Logic works. You have like specific channels for the effects, and you can send whichever dry sound through the effect. And this is also better because reverbs, in particular, are pretty heavy on the CPU because they make a lot of calculation. So if I'm making a composition with 200 SYNDEFs and each one of the SYNDEFs has its own reverb, it will be crazy. Well, you can do that, don't worry, but it will put your computer, your CPU in more stress. But if I don't know, if the half of that SYNDEF go to the same reverb, because let's let's face it, in the composition, you don't need 200 rivers. Usually you just need to put things in perspective, you know? Usually you want things in the back, you want things in the front, and things that are a lot more drier. So it's like 5 rivers could solve the whole problem, usually. I'm not saying that you can go over the top and have a lot of rivers, but it's better to send more sounds through one river, right? While also I can show you this. I don't know if I have showed you. Yeah, I showed you for the done action. So as you can see, the river is still on, and that's okay. I have to, because the river I haven't freed it. If I put b.3, then the river will be freed, and then if I run my snare, it's dry, right? If I get my river going and then now I have it. Obviously here I'm using a really excessive, really wet river just to make it super obvious, right? I can make it this a little bit more subtle, obviously. Now the river is pretty. So that's basically what I can do. I'm gonna put this back to the original sound. I'm gonna copy this stuff like this to this, so you can have it like this. Actually, the boss needs to be, yeah, this is the order of execution. You need the boss before you actually, obviously, if for some reason I restart my server, there I restart my server, add my river, and try to run this, it will work, but boss doesn't exist. Or boss exists? Let's see. Okay, as long as Super Collider is open, the boss will exist. If you close and open Super Collider, then you have to rerun this line, right? To make that boss present in the server. So, wow. So I don't know, that clarifies some things regarding done action.
Sorry?
So that clarifies a little bit of how done action works and how you need the effects to be in another place. And also, now, if you run this in a P-bind, it will work correctly because the P-bind will be activating the snare, and the river just will be one instance of the river, because the river will be like just getting on in background, right? So it won't choke out the server like it will do a lot of snares without the done action. So basically that's the difference.
Okay, just for the reverb, so you in the arc you assign the bus to 0, you know, like to you by default, but the bus is actually, so bus is not an integer, so it's an object. So in Super Collider, like assigning to 0 is equal to, like, I don't know, in Python assigning to none or like this kind of stuff.
In this case, I'm just assigning to 0 will be just assigning to
like the empty object.
Exactly.
Okay,
at least
so
for the bosses, but here I'm assigning out to 0.
To the actual 0 value. Yeah.
This is a 0 actually corresponds to a boss, corresponds to the, like, this first boss, right?
Mm-hmm.
That doesn't have, by default, is just the output, right? So, but here in the boss, here that it asks for a boss, it will be an empty boss.
Okay.
I think that if I don't run that, let me see if that will work just like that. Just to, because I'm not sure if that's empty and I can do that. I will go put my, so I run my, if I run the voice like this, and I run it like this. That also works. Here, I'm not assigning it to the boss called boss. I'm just sending it to bus number 0.
0.
And I'm just sending this to out number 0. And that worked. The problem with this is that everything that goes through my left speaker will be affected by this river, because it will be like the actual output. And in this way, using this variable, it will be like an individual virtual bus. That's the difference.
Okay.
So I wouldn't recommend to send it directly to 0, because all sounds go to 0 and you don't want to affect that. But just maybe you have like a general river and you want all your objects to go to that river. So then that's okay. Put it to 0 and it will work.
Oh, yeah, that's better.
Yeah, but it's better to have like the individual buses that actually control the things you want the way you want. So cool. Is there any other question? We're good then. Cool. So today we're going to go through a little bit of more subtractive synthesis, well, filters in general. And we're going to learn how to make a GUI. GUI stands for Graphic User Interface. So we can make buttons, windows, sliders, and all types of stuff to control visually with the mouse and with an actual interface, control our code and not dealing with the actual code. So first, we're going to go and see this object called rings. Rings is a ringing filter. But basically, that means a resonant filter. Here, the description is awful. I hate this description because it says that this is the same as resonance, except that that is a constant skirt gain filter, meaning that the peak gain depends on the value of Q. And the reason I hate this is because if you usually, okay, if it says the same as resonance, I would expect a good description in resonance, but resonance description, it says this is the same as rings. So this is pretty well bad. But basically, this is a resonant filter. Resonant filters work kind of the opposite way of normal filters. So you have this spectral content. I don't know, a lot of, imagine this is a sound that contains a lot of sine waves, right?
What is this?
It will be just a sound.
Sounds.
Yeah, sound that contains, so this is the spectral, and this is timbre. So it just does, yeah, it's the harmonics of the sound, hypothetical sound, right? So normally, sorry. In a normal filter, you choose a frequency.
Hi, Michelle. Hi, everybody. I was late because problem paying a workshop.
Yeah, don't worry.
Hi.
So in the other, you choose a frequency, and the filter filters from here or to here. But this one, actually, you choose a frequency, in this case, this frequency. And instead of taking this part of the spectrum or the other part, it basically what it does is it enhances this part of the spectrum. It makes it more resonant. It gives more amplitude and more resonance in time. So it makes it strings. It resonates this part of the spectrum. And so
it is a band pass?
No, but this is a resonant filter.
Okay.
So yeah, it works kind of a bandpass in the way that you choose a frequency. Usually the bandpass, it will just let pass whatever is in the band and it will filter above and below. But in this case, this wouldn't filter, it would enhance. So it's kind of the contrary to a normal filter. I actually wouldn't, myself, I wouldn't call resonant filters because they are not filtered, they are enhancing, a resonant enhancer of the, so it's kind of the opposite, but it works pretty well because you can also have a sound and make it resonate the way you want. So I'm gonna show a real example of that. For example, let's use this object called impulse. Impulse is an impulse oscillator. It outputs non-man-limited single sample impulses. So basically, it's just it outputs a sample. Basically, this is a click noise. It's a. If I run it, it just asks for frequency. In this case, frequency doesn't actually, well, it kind of, but it's not a direct correlation with pitch. It's basically how much impulses you want per second. So if I put 1, it will be 1 impulse per second. Let's hear it. It basically is a click noise. You can hear it?
Yes.
If I put it 3, it will be like triplets. Tick, that. If I put 10, if I put 100, I will start to get pitch because this will be enough fast to make a tone. But if I put it just by itself, I will scope this. So just a click. So a click noise, it actually has all the spectrum because it's just a slice of noise. So in a way, this will be pretty similar to a white noise in the sense that it has all the spectrum. So it's a good thing to be filtered. So rings, let's go to rings. This is our first resonant filter. It has as arguments the in, so basically what you want to resonate, an input signal. Then frequency, the resonant frequency in hertz. Then a decay time. This decay time is how much time you want that to be resonating. This has to be in seconds. By default, it's in 1 second, so it has 1 second of resonance. And then it's multiplicator. So if I go to argument, audio rate, I want to resonate my impulse. And I want to resonate, I don't know, 300 hertz. Put this inside a function so I can hear it. Now it's resonating. I can change the resonation. So it's pretty cool. I still can hear the timbre of the impulse because this is still an impulse. But now I hear like a toot 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 kind of bellish metallic sound, right?
I have one question. It will be the same if we use an impulse with KR, or we should only use an AR in this case?
In this case, this is expecting audio rate signal. Because if I put it to KR, then it wouldn't, yeah, let's hear it. And you can say that the preceding error is for rings first input is not audio rate. So you can give it another rate because this is a filters acts on signal. You can't act on data. So it's important that you feed it with that. Wait, not data, I mean audio signal, actual signal. So yeah, sorry about that. So yeah, if I then change the decay is pretty important. So if I put 0.1, it will just resonate for 0.1 seconds. You can see it's pretty different, right? If I change this, and I can go over the top and put 3 seconds. This will be kind of annoying, but let's hear it. So now the reason it's annoying is that each impulse is resonating over 3 seconds. So they are overlapping and they are summing up amplitude basically. So for example, if I put 1, and we'll make it resonate. So that will be 1 impulse per second and it will resonate during 1 second. So that we'll hear it during exactly and over time. If I put a little small resonation, I don't know if you can still hear the resonate. It's really small, but it's different from the original impulse because it has like that pitch. If I put the pitch really high, it will be more noticeable. It's basically like it's kind of the same pitch of me clicking my tongue. So if I put it really low, it wouldn't be that noticeable. But the moment I change this, almost
What is
feels,
this now?
yeah.
What you did? What
I
is
didn't-
it? What did you change?
I'm changing the decay time. So the basically it's the time of the resonation. How much time did you want to resonate? For example, if I put it like really high, it will resonate. Each impulse will resonate 5 seconds. If I put it really small, so it's the time of the resonation, basically. So much time it vibrates, basically. But well, it's not vibration because you know it's basically resonation. So is that kind of clear?
Yeah. Is it possible simply to just double the 61 line and to put instead of 0.1 to the second 0.2, and then we would have two bits at different steps, and then we could start to make music. Is it possible?
It's possible to have like 2 pulses, or what's the question?
No. If I continue my process with what you explained, if I would like now to start making music with it, I will repeat this line on the line 62. Now we are on 61.
You mean like this?
Yeah, and for instance, I will create another sound. And instead of, for instance, of 0.1 second, I would put a longer input, 0.3. And would it be possible to play it together?
Yeah, let's do that. For example, I put 0.3 and I will make this, I don't know, 3 seconds. And 3 impulses, and I will just do it like this, right? To have different. So this will be, for example, I will do like this, to have like this rhythm, right?
Yeah.
2 against 3, right? Like that, this will be. Yeah. This one resonating on 80, this in 230, and this will have the low one will have more resonation. Well, this is not like the best way to do it, but if you put like a command at semicolon and you just run it together, they will sound together. And I get the real tune. It's not, well, yeah, not the more musical thing in the world, but yeah, it's possible.
That's possible.
Yeah, obviously this could even be better if you make it a synth out of it, so you can control like the entrances and you can give it envelope. The only problem with impulse is that always that, I don't know if that bothers you, but a lot of people don't like that clicky sound. You know, there's, I once made I made an artificial soundscape using synthesis, and I make like a lake and then sounds of the animals, and I get pretty obsessed with that. And I made rain using impulses and resonant filters, and it was pretty cool because it was binaural and everything. But my composition teacher didn't like it because of the clicks. He wanted me to eliminate the clicks. So if you want to eliminate the clicks, I will use a different impulse because the input can be anything. It could be a recording, it can be your voice, it can be an instrument, it can be another synth, it could be a really well-made synthesis sound. So here I'm just using like a really plain click sound just to demonstrate the way of working. Actually, let's do that and change this. For example, I'm gonna put it here. I didn't copy anything. Actually, let's change this to, for example, a white noise. Because with white noise, this behaves pretty different. I'm gonna put something that's pretty soft because you know white noise can be pretty loud. Here, I'm gonna change this to a really small resonation. What is what a really small resonation? With impulses, the resonation is pretty straightforward because you can hear the pulse. But white noise is continuously. So if you put a really big number, the resonation will be like per sample, and it will start to get really clocked up and really high in volume. So let's hear this. And this isn't working because
Michelle,
yeah, because of this.
0.1 is the multiplication, the mole of white noise, yeah?
Yeah, you mean this?
Yeah, it's the mole.
Yeah, it's the mode of the white noise. This is the
Okay.
frequency of the resonant filter,
Uh-huh,
and this is the decay time of the resonation.
yeah.
Well, it has the multiple ones, and one will be multiplied by 0.1, right?
Mhm,
So
mhm.
let's hear this now. So I'm gonna give it a more higher pitch. I'm gonna make it a little bit. So now you can hear that it's resonating that frequency in the white noise, right? If I change it, it changed. So that's pretty cool, right? But what if I want to apply more resonant filters to white noise? A lot of times resonant filters are used like in physical modeling synthesis. We're not gonna get through that because it's a lot of theory, but we're gonna see how they are used in the way that you can use more than one at a time. Obviously, one will be just like, you know, put one on top of each other in a SINDEF. That will be a one. But the other idea will be to use this object called clang. Clang, I mean. So this kind of clang that we already use. The clang is a bank of resonators. So clang is a bank of fixed frequency resonators which can be used to simulate the resonant modes of an object. Each mode is given a ring time, which is the time for the mode to decay by 60 decibels. So basically, this is a bank of rings, okay? Kind of the same way that clang was a bank of sine oscillators. So let's go through this. So yeah, let's take the 10-minute break now. So then we can continue with this and then start with take 15 minutes to go through clang and then use the rest of the time to go to GUI. That's the actual topic that I want to go, how to make windows and everything. So let's get everybody back in 10 minutes. I'm gonna go for some coffee.
Ouais, c'est une bonne journée parce que j'ai plus de semaines.
I'm sorry. Hello, I'm back. So just tell me when everybody's back. I can see Quentin. I can see. Not sure, but I can see you. Yeah, so let's wait a little bit. Start getting back. You can see Thomas. So we're most of us, we're just working on Panayotis and simulation. Cool. So yeah, Clang stuff. So Clang, as I was saying, it's a bank of resonators. So it has to be out rate. It can be control rate because it's actually it's enabling the use of rings as audio. The first is ask is for the specification array reference, so the array of arrays, just with like with Clang. Remember, it's Clang for the sine waves and Clang for the filters. So it asks for our frequencies, so basically an array of filter frequencies, then amplitudes and ring types. And as for the input and frec scale and frec of scale, so a scale filter multiplied by all frequencies at initialization time. So let's make a SINDEF with this. Why I want to make a SINDEF? Because then I want to use this SINDEF with my GUI we're going to construct today, build, I mean. So SINDEF, I'm going to put this ringy, because of the resonance stuff. Play. So arguments, variables. So input. For input, I'm going to use the white noise. Then I'm going to go to this signal. So for signal, I'm going to use Clang, obviously. Specification array reference. So remember an array of 3 arrays. Here will be input. I want to separate these arrays just to make it more readable. There we go. So here I'm going to put arguments. So it will be frec1, frec2, and frec3. Amplitude 1, amplitude 2, and amplitude 3. So that way I can control the level of each frequency, so I can make a mix out of this. Obviously, I can use more than 3 frequencies, just to make it easier to control. And in this case, the resonant, I don't want to be that changeable, because like I said, if I put more resonance, that would, in a white noise that is a continuous input, it will just end up being more amplitude and not the precision of resonance. So I'm just gonna put here 0.1, 0.1, and 0.1. Just hard code this. Then I'm gonna put this through a banner to make it what I did. To make stereo, I mean. So signal, and I'm just gonna put it in the middle. Also, I can make it go through a river, why not? In this case, the river will work because, like I said, it's a continuous sound, so it wouldn't affect that done action stuff. And I can put this directly to out. Let's see this. Oh, obviously I have to put the frequency 1, 0, frequency 2, 0. But I'm putting it in 0 because I want this to initialize just as a white noise without the actual affection of anything. 1 will be 0.1. I could copy this. This will be amp 2, frequency 3, and amp 3. And I think this should work. If I activate this will sound just like a normal white noise, right? Because even though the clank is acting, it's acting through 0. This is weird. Why is it not working? Ring is working, maybe. Oh, of course, they have to make this audio right. So whiteness. There we go. So we'll add this. It's weird. Sorry. So now I can go here and go synth. I will copy this to the chat if you want just to copy it directly. Synth ringing. X equals to that synth. X set frequency 1. Modify these arguments. And then there we go. So now I can start doing this. Why is it working? Oh, of course. Now this is important. For example, you guys see here the discussion. The parameters in the specification array of reference can't be changed after it has been started. For a modulatable but less efficient version, see the incline. So the incline, it says that is it's the same stuff. It's just like unlike Clank, all parameters in the incline can be changed in real time after it has been sorted. So I have to change this to DIN. that din basically starts is this dynamic clang. So I can now instance this, and now I can use it again. So I have enough control of this by affecting the frequencies and the amplitude. So before I continue, is there any questions regarding this?
Will you show us during all the class when we can, how we can take this, for instance, and this output and go to Ableton Live, for instance, and receive this the signal? Is it possible? It makes sense?
Do you want to send this signal to Ableton Live?
I mean, if you work like that, if you improvise for yourself, I was wondering what's the best way to use it in our music, like to compose or to play live. So maybe today it's like playing live because you would show us how to make a GUI and maybe use an interface. Yeah. And if we edit, if we make some improvisation and after we can edit different parts of experimentation, what would be the best way? Should we do that in Super Collider or should we do it in another software?
Okay, you can do it. Well, you can do all the options you say is possible. For example, you can like make a whole improvisation in Super Collider and record it. So you can just directly send that WAV file to Ableton and then use it in Ableton. That will be one option. Another option will be to directly send the signal to Ableton Live. So Ableton Live will be in real time affecting that. That's also another option. Also, one that I use with specifically in that scenario is that I use p-lines in Super Collider, but because I really like the algorithmical like motor of Super Collider, but I make them produce not sound but MIDI, and I send the MIDI to Ableton, and I use the Ableton synthesizers that are pretty gorgeous, you know, because they have like marimbas and basses and stuff that will be pretty difficult to synthesize from zero in Super Collider. I'm not saying it's not possible. I'm just saying it's difficult, and sometimes you just want that synthesizer that you already have, or you buy a VST or whatever. So you just send, so you can make like use the sound motor of Ableton, but use the power of algorithmic in Super Collider, and that's super easy to do. actually, that example we're gonna make it in class in the MIDI session.
Okay, cool.
What I'm gonna show you now, and that's because you asked, is how to record in SuperCollider. So there's like a couple of options. The most easy one will be go s.make window. I don't know if I have showed you that, but this actually outputs a GUI. This is a GUI, as you can see. This mutes SuperCollider, so you have a mute button. This controls the general volume. You can even go and put it like this directly. And you can quit the server, boot the server directly from here. So I'm gonna put this here just because I need to add this again. And if you go here and go record, it says that SuperCollider is recording channel 0 and 1, and it's recording in that path. So if I start to make sound, I just record something, and then I go here and I make stop. So now I record that in audio, and SuperCollider sends it to users, Michelle, music, SuperCollider, recordings. So basically, everything that records will go to this folder. Usually, I just go through my Finder and I put SuperCollider recordings. There you go. I open that folder. Well, I have a lot of stuff, as you can see, but in your case, it will be just one file. So that this file, if I open it, for example, I would open it with Audacity. In a moment, I will tell you why I open it with Audacity and not directly with Ableton Live. So now I have my sound recorded, right? So now it's a WAV file, I can use it wherever I want. Actually, when I started using SuperCollider, and I wasn't like fully acquainted of how to produce a total composition, I just make the sounds in SuperCollider, I record it, and then I organize them in a the DAW, in a DAW. So this is worked perfectly. The reason why I open it here is that SuperCollider by default creates this this AIFF extension, basically because those are multi-channel data. So for example, if you record a 16-channel composition, it will record in just one file, and that's pretty convenient. But the problem is that some, for example, I think Logic doesn't open that AWF-F5, so usually I just open it in Audacity to convert them into normal IF of WAV or MP3 or whatever I want to use in the next software. And it's pretty cool because you can record as much channels as you want. So that's also, you can go s.records. That also will work. Yeah, and I think it's s.rec channels. Yeah, where you choose how much channels you, for example, 8 channels, and now, and if I start recording, you can see that SuperCollider now is recording channel 0, 1 up to 7. So you can record as much channels as I want. One time I made a 16-channel composition for a dome of dome speakers, and I do it everything in SuperCollider, and it worked very well. Yeah, also that time I composed that without the actual dome because I do it in my house. So it was kind of a fade composition, but then I rendered the 16-channel into a binaural, so I can hear the whole composition in my speakers, and then I transform it into Ambisonics format B using SuperCollider because there's an extension from that, and I send the format B to them, and they just have to decode it, and in that way I didn't need it, and I didn't need to send the 16 tracks. individual,
Mhm.
just the format B. Format Bs are I don't know if you're well acquainted of ambisonics, but there are 4 channels because they have like X, Y, Z, and W axis. So yeah, cool. So that's basically the way, but you can send also data too. Also, SuperCollider is pretty good with OSC messages. So you can send OSC through to Ableton Live or to
Okay.
processing or to whichever software that can go work with OSC messages. So
And if you do OSC, you have to do a code, like to an object, or
Yeah.
to put it.
yeah, you need to use to go through OSC definitions.
Okay.
Yeah, I think it's like this. Yeah. OSC definition, and you have to get an address. I can show you an example
Yeah. Okay.
in another class, but yeah, SuperCollider is super good with connecting stuff. Also, it's a really good language to manage data. For example, sometimes I use SuperCollider just as the brain. So I get the data, I process the data, and then SuperCollider sends signal to the other software that will actually output the either visuals or music or whatever I want.
Okay.
So yeah, it's pretty cool, SuperCollider in that matter. I can show you some examples later.
Yeah, it would be great.
Yeah. Even maybe I can arrange. I'm making like a project with my girlfriend, and she's like processing data from SuperCollider to make visuals with a 3D environment.
Wow.
So maybe I can arrange that one of the classes she can show you that to you.
Yeah.
Yeah, she's using this software called Notch. That is it's a Windows only software, but it works with visuals and 3D geometries and everything. It's pretty cool. But basically, what SuperCollider does is just send data to that to like visualize the data. So it's cool. So let's go now with GUI because I'm running out of time. Sorry. So let's do with GUI. So just wait me a minute, and then we go to GUI. Sorry, I'm back. Sorry. What's happening here? Yeah. So yeah. Hello, Thomas. Sorry if you were waiting too long. I was in the bottom. Sorry. So let's go through GUI. So the GUI, the first object that we need to use is this object called window. basically window is like the superclass for all things that has to do with GUI. If you see that Windows says it's a GUI and it's from the window views family. It says that the top level container views. The window is the most fundamental element of GUI. Remember, GUI stands for Graphic User Interface. It occupies a rectangular space on the screen within which other GUI elements are displayed.
Graphical user,
What?
graphical GUI means
Graphic User Interface.
user. Okay.
Yeah. Basically, it will be, for example, we are pretty well used to GUI. Normal, for example, when we deal with normal software, usually all the time softwares are used with GUI. For example, even SuperCollider has a lot of GUI. If I go here and I go File, for example, the pop-up window is a GUI because I don't have to deal with the code. It by default, it performs things when I click on stuff. Usually, for example, normal software behaves that way. For example, we deal with in our phone, our apps are just GUI. We don't deal with the code that is activating the apps. So yeah. Then it says that a child view is added into a window by passing the window to the views instruction. This child stuff is pretty common in programming languages. When you call something a parent and a child is an object that needs a parent to exist. That means, for example, a button. You need a window to display the button. So the button will be a child that depends on the existence of the parents to exist. And this is pretty normal. So basically, in programming languages, a child means that it depends on the existence of another object to be possible to use it. And before, this was using master and a slave, it was called. But I think that now it's kind of, well, they take it because it sounds awful. so they change it to parent and child, and I think it's better than, just to avoid the connotations of the other words. But there's still programming languages, I think C, that still use that master slave slang because they were programmed back in the days. I think SuperCollider has like 15 years of existence, so it's a pretty new language in that matter. And it was also back in the days that this object-oriented paradigm didn't even exist. It's pretty new. So actually, SuperCollider can do a lot of things because it can do programming language, imperative language, and declarative object language in the same language. That's why it's so powerful. So well, that was a question. Cool. Like said, there's a little note here that there is no distinction between windows, views, and containers. A view can be displayed direct on the screen and can contain other views. Therefore, visual description of windows and most of the methods that are specific to window in other GUI kits also apply to and make part of view in Qt, and are thus shared by all these subclasses. The window class is provided in Qt GUI for compatibility as well as convenience. Unlike view, window will be created by default in the center of the screen, and various aspects can be combined and controlled using its constructor arguments. So in this way, window will be like the syntax of views. It will be the container. So we will window.new.
So just for instance, the character you are typing, is it a GUI? Is it a parent of something, or sorry?
What, can you repeat that?
Yeah, I was wondering in the SuperCollider about the topic of the GUI. If when you type window.new, can we say it is a parent or a child of something?
Yeah, window will be the parent of all the GUIs,
okay.
Because if window, it will be just like a rectangular stuff in the screen that will contain the other GUIs that actually perform stuff. Window by default, it doesn't do anything, it just contains the other views. The ones that will perform actions will be, for example, buttons and sliders and knobs and that type of stuff. So window, as its first argument, it asks for a name. and it asks for a string. In SuperCollider, a string is defined by this. So if I put hello here, it gets a string of characters, because if I just try to type hello, it doesn't exist, but as a string of characters, they work. So I'm gonna put this ringy. Why ringy? Because basically I want this ring to control ringy. So then it asks for bounds. Bounds is a rect specifying position and size of the window. The size does not include the border and title bar. Position is measured from the bottom left corner of the screen, so from here. The default size is 400 by 400, and the position is this. These numbers are measured in pixels. So basically, the limits of the size of the window will be the size of your screen. Basically, you can make a window that is bigger than your own screen. But if you change to another monitor that is bigger, then you can make the window bigger. So for this, I need this object called rect. And it asks for left and top. So this is coordinates in X, Y axis where I want my window. So for example, if I put 0 and 0, that means that my window will start be created from here. When you in Mac, when you have like myself like this dog leg that is like it doesn't hide, then this is like the border of the screen. I put 400 times 400. This is basically width and height. Then I have to put front. Because if I don't put front, it happens this. It says that it creates a window, but you can't see the window. That's weird. Because you tend to tell it, well, where do you want the window? So if I put front, we create the window here. So you say, here is the birth of the screen, 0, 0, and it's 400 pixels in height and width. And I can move the window. Put it here. Obviously, if I put it here and then I press SuperCollider, it goes to the back. And I really don't like that because especially when I'm building the window, because it's pretty annoying that it's going back. So I also put this called always. This is another method. Always on top. Always yield, no, always on top. And I have to put here true because it asks for a Boolean. So if I run this like this, now it always be on top of stuff. So it survives that. So, and now I want to change its place. I'm gonna put, I don't know, I wanted something like this. Yeah, because I don't want it to be here on my code. I want to be on top of my win here, because so I can code freely. So by default, the Windows doesn't do anything.
Okay.
W equals to window. I'm just making this to make. So I'm here. I'm going to put my window. So let's go to the first object that we can use inside window. Well, it's not the first, but it's like the most common one, button. So this is, as you can see, it's class GUI and it's from views, and it's a multi-state button. That means that it can change the state of the button. So, well, it says that some important issues regarding button. The button performs its action upon releasing the mouse. In musical context, you might want to use the mouse on action to set a function to be performed on pressing the mouse. So basically, what's training it by default button isn't very good. For example, if you want to play like a rhythm or something, because it will be performed when you release the mouse and not when you push it. So it's not really good for playing stuff. That both for activating stuff, that's pretty good. So button ask by itself, it just asks for a parent, So that means where you want it to be displayed. So as for a window, and then for bounds. So if I put button.new, parent, I want parent to be W. So that will be the window once it's created. And for rect, now the coordinates of left and top doesn't stand for the screen, are now the pixels that are within the window. So if I put 2020, that will be coordinate X and Y20 inside the window. And I want this button to be small. I run this and I'm missing, I'm missing this. So now I have a button. Cool. It doesn't do anything because I didn't tell them to do anything, but it works. So now, and this stands for almost all objects. If I go W dot background, I can change the color of window. For that, I need this object called color. So I'm gonna use this just by default, and then I'm gonna explain further. That doesn't work because a background color has to be maybe. No, maybe black doesn't exist. Color dot blue. What I'm doing wrong is, okay, let's go to window. Sorry, something is not working here. Let's see. Close, inherited view, pass view, front, minimize, full screen, always on top, close, close, bounds. Appearance, yeah, background. Yeah, it has to be background. Maybe I just need to do it like this. There we go. So then now I can change the, it was background with the hyphen and not background color. So if I go to color, it's an object which stores color values. An object which stores red, green, blue, and alpha values in instant variables. So instead of, if I use new, instead of the one that I'm using, I can give it red RGB values. For in color theory, that's basically additive synthesis. You are using 3 lights to make color. So if I put, I don't know, 1, 0.3, and 0.7, I will get a new color. That's pretty cool. I got like this cool pink. But usually it's very weird to think colors in 0 to 1 because normally the RGB protocol works from 0 to 255. So if you are already working with something like Adobe or something, those are normal numbers. So I can use new.55, 255. So now I can give it, I don't know, things like this. I get a different color. For this, instead of trying to guess colors, just like I'm doing, you can go here and you can go RGB wheel online. This is the one that I want. Yeah, this is pretty cool. Go to this color spire and you can choose, I don't know, I want something like lavender color, something like this. Yeah, I want that color. So here it gave me the RGB and the HSV and also the FFT. I mean, no, not called FFT. I'm gonna look at that. But it gives me like the coordinates. So I can have 230. I'm gonna say this in Spanish just to remember. 213, 50, 197. 213, 50 y 197. I think that was. And I get the color that was in here, right?
Michelle,
Yeah, please tell me.
can you use the number D53, the 53 to C5?
Yeah,
This, yes.
Yeah.
Can you use, it's easier.
Yeah, it's easy. Depends on which one you are like used to do. If you want the other than that, you're going to have to go this one, hex string. So if I go color dot from hex string, then it asks for that string.
Hex, hex means, yes, okay.
Yeah, this hex string. So I, for example, I want, I don't know, I want
Hex, yes.
I want something, I don't know, like, I want that color, for example, I like this one, and I just copy the hex string. Sorry, and I have to put it.
Hexadecimal, I think.
Yeah, it's hexadecimal, exactly. I need this, and it has to be a string, so I have to put it inside this, so it's a string. Cool, I have that color.
I think it's easier, hex string, huh? Because you can copy one number and paste it, and so.
Yeah, myself, I'm not a really fan of hex string. I'm more RGB because that's the way Illustrator and Adobe works. And then, well, I think you can work with it, but it doesn't matter. You can go whichever you want. Also, you can go directly black, white, gray, red, green, blue, cyan, and magenta, yellow. And also, I think here, the class itself gives you a lot of colors, like, yeah. And it gives you the RGB of antique white, aquamarine, azure, bisque, blue, violet, brown. So it has like all these colors. It gives you options. And it gives you,
yes.
And it gives you, I think this is the name of the color in Pantone. So yeah, so it's cool. I usually don't put a lot of attention into color in my GUIs, but I usually use myself. I use white and dark, but you can go crazy in this. You can even put a photo of your dog inside the GUI if you want. So you can go really, really specific in this. But for now, we're gonna leave it in that greenish color. So cool. I have this, and I have my button here. Look. Cool. I like it. I'm gonna put it a little bit down.
Can you put a fader, slider?
Of course. Yeah, of course we can. Sorry, I'm putting in a place that I can. That's better. Yeah, you can put a slider, you can put a knob, you can put a lot of things. So let's work with the button first. So I'm gonna call this button P equals to button. So let's go to button. Let's make this button make something out of its life. So here, the states here. States is an array of labels and colors defining the states of the button. So it's an array of arrays. So if I go B dot states, states. A lot of GUI methods ask for this. What's the name of this in English? It's like, I don't know, hyphen, but I think it's like low hyphen. I don't know.
Underscore.
Underscore. Thank you. Yeah, the underscore. The reason they ask for the underscore is because this states method also exists for other objects that are in GUI. So basically, it's just to know which one stands for GUI and which one stands for other objects that doesn't have to do with visual elements. And it's a pretty common mistake that you forget the underscore and the method doesn't work. That was what's happening first when I take off this background. You see, it doesn't work until I put that. So cool. State. So it asks for array of arrays. So array of arrays. Each one of the arrays contains a state of the button. So in the first, it asks for string color, and background color. So first, the name of the state. So I'm going to put this off and on. If I run this, then I got off and I got on. So now it has two states. If I can, if I add third state, I can put this, I don't know, taquito. So now I got off, on, and taquito. And I can put like infinite states in this, and if I want, usually you want a 2-state button, but in some cases it's cool to have a 3 or 5-state button. For example, if this button is controlling the piece, like you can get section 1, section 2, section 3, and go through the states of the button. I'm gonna take taquito because we don't really want that. I just want this to be the button that gets my CNDEF running on and off. Then I can put the string color. So I will put, in this one, I will make my string color be color dot black, and the background color to be color dot white. So now I changed white isn't yeah, it doesn't work. Why did it work? Because it has to be the other way around, because by default is that. There we go. Yeah, and now my button has a different color. So it's just to know when it's on and when it's off. Cool. So now, yeah, I have the button. So now I want this button to do something. For this, I need to do, where's this? Action. Action is to perform an action when the button is pressed. So if I go bot.action, it's asked for a function. So wherever I put inside the function will be the action of this. Obviously, by default, it doesn't do anything. So first, I'm gonna open here arguments. And if I put, I don't know, but or button, whatever, a lot of times when a method asks for an action and you open, like I did, an empty argument, that argument will refer to the object itself. I don't need to specify that the action knows that if I put an empty argument, refers to the button itself. So if I put bot.value.postLine, it will post the value of the button. And it didn't do it because I don't know why. Why I'm doing here? Of course, underscore. There we go. And now you can see that it's posting the value. So on is 1 and off is 0, because basically it corresponds to the state. If I add a third state, then it will be 0, 1, 2. So now I know that in data, this is the name, this is the number of the button. So now I can add something to it. Up to this point, are we clear or not that clear? Cool. So for this, I want the button basically to, when it's in 0 to perform an action, and when it's in 1 to perform another action. So for this, I can use a conditional. That will work. But if I have more than one state, a conditional won't work, because conditionals work with Booleans. But what I can do is use a multi-conditional. So I can use this object, this method called switch. So let's go and see what switch did. I can go here in control structures. No, maybe an object. There you go. So switch is object implements a switch method which allows for conditional evaluation with multiple cases. These are implemented as pair of test objects, correspond whatever. So let's get this and make it easy to understand. I don't know. Sometimes the help window examples are very weird. So I'm gonna go like this. So I'm gonna just put 1, 0, and 2. So this is just C equals to this array. So if I put C dot choose, every time I run this, I will get one of the numbers between C. So basically, switch method asks, so it asks for a conditional. This will be the conditional, C dot choose, and then the options. So if I get a 0, I get this. If I get a 1, I will get this. And if I get a 2, I will get this. So I will put this. Yes. If I get a 0, post line. If I want a 1, I will get no. If I get a 2, I will get hello. So if I run this, yes, 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 hello, no. So now it's outputting the value depending on which number I get. I will put post line here so we can see the correlation. 0 is yes, yes, 2 is hello, 1 is no. So basically with switch, I can get, okay, check the state of the button in this case, or whatever data, and depending on which number it gives you, output something. So very cool. So I can go, okay, up to here is kind of clear.
Michel,
Yeah.
I must leave.
Oh, okay.
Okay.
Don't
Have
worry.
a nice time. Have a
Yeah.
nice time, everybody.
Yeah, yeah. I will
I
post.
continue in the video.
Yeah, I will post the video. Don't worry about that.
Yes, yes. Thank you, thank you.
See ya.
Bye-bye.
Bye.
Bye-bye.
So, did anybody has any question regarding this switch method? We're good? Okay. So, cool. I'm gonna copy this whole stuff of the switch method. And I'm gonna put it up here so you can remember it later. There you go. So in here in the action, I will take this and I will use switch. The conditional will be bot.value. So basically it will be the value of the button. So if I get 0, I get this. If I get 1, I get this. So, and close this. There we go. So I will put here hello. And here goodbye. Goodbye, hello. So now the button is performing the action. And remember, inside a function, I can put whatever I want. I can instantiate SINDEFs, I can run pipines, I can do whatever I want because functions make it run in the real time. So here, instead of the hello post line, here when I'm in the one that's on, I want to go x equals SIND ringy. And the 0 will be x dot free. So I run this. And now it activates my ring. Pretty straightforward. Usually, and that happens a lot at first. Usually, GUIs has a lot of code, and are kind of boring to make. But once you make one GUI, you can just copy like the structure of that GUI and modify it to affect everybody. At first, I didn't memorize this code. By now, I have it memorized, like how to construct the GUI from 0. But at first, I was just copying my own code one on one. Okay. I actually didn't memorize it by making a lot of GUIs. I memorized it by giving these workshops. So don't worry if you just copying this code. For example, SINDEF. SINDEF is something that you want to have like really handy in your brain, like really know how to build SINDEF from 0. But GUI, you don't need a lot of GUIs really. You can have like a master GUI and just copy it and copy it and copy it. So now I have it working here. Super cool. So now I'm gonna add a slider. Well, before that, any question? Cool. So for slider or for faders, so the way you want to call it, this object called slider. So slider is a view consisting of a sliding handle, a view that allows setting a numerical value by means of moving a sliding handle. It can have horizontal or vertical orientation, meaning the direction in which the handle moves. So by default, I will put slider.new. And once again, it just asks for parent and bounds. So I'm gonna put rect. I'm gonna put, I don't know, 60, 20. Width, I want to be 20 and height 100. And I'm missing a parenthesis. Cool. Now I have my slider. That's kind of not in the best place. There we go. I like it there. So I can make it, you know, pretty large. That was a lot larger. And also I can make it like this, no? So basically the orientation depends on which number is bigger, either the width or the height. Here that I'm running a GUI and over again, it's not changing the actual GUI, it's making new GUIs, as you can see. So yeah, just for you to know that, you have to be right. So this is a problem in the sense that when you're building the GUI, you will have a lot of GUIs because every change is a new GUI. But once you have like the actual GUI, you just have to run it one time. So cool. So now I'm gonna put this equals, I don't know, C equals its slider. So let's make that our slider do something. This is the same way, action. So I'm gonna open an argument and I'm gonna call it slide from slider. And slide dot value dot postlight. Why I'm do this? This is just to have a way to know which numbers my slider output, so I can manage the data. So I run this, and I can see that in the bottom, my slider goes from 0 and up in float numbers up to 1. This is the way all the sliders behave. They output numbers from 0 up to 1. So this is cool. So let's manage this data. I can go slide dot value. I want this slider to control the frequency, the first frequency of my ringing filter. So I can go x dot set frequency. Obviously, x will exist once I run ringing, right? So I want the slide to control that. The problem is a slide goes from 0 up to 1. That's not numbers that really works for. So I can use this called lean. Let's see how lean behaves. Lean is basically a mapper. It's mappers values that are linear to new values. So you got in min and in max, so the values that you're receiving, and you have out min and out max. In this case, I'm going to use lean x that basically maps the in linear values up to exponential values because frequency behaves that way. So I can go f's. So I have 1 from 0, that's the values I get from the slider, and I want to go from 40 up to, I don't know, 3000. I run this. I'm missing a parenthesis. Oh my God, wait. Sorry. There we go. I run this. And this is not working. And this doesn't work because the percent error is for message link. Okay. Because it has to be a slide.value. Because slide by itself, it doesn't make sense. Let's see if this works. This is still not working because frec doesn't exist. Frec1 exists. So now I can control the resonant frequency. Obviously, if I try to run this, it makes me this error. Why? Because actually what this action does is every time I move the slider, it performs this function. So it's trying to make an X set to an X that doesn't exist, because I need this to have running. Cool. So is there any question regarding what I just did? No, we're cool. Okay, so now it works. So now I can make a slider for each frequency. For this, it can be pretty easy. I just can copy this structure, change this variable D and D, change this to 120 or 110, maybe will work, and make it 20, frec 2, and now I have 2, right? Cool, and I can make another one. 130. 140. A, B, C, D, E, frec 3, and there we go. Cool. So up to this point, we're good. Any question regarding GUI or what I just did?
Michelle, I have a question.
Yeah, please.
Do you have to keep the GUI elements, the GUI program, these functions in the same file as the syntax?
No. No, you can have, for example, just one file with all the syntax, one file with all the p-lines, and one file with the GUI.
How do we, I mean, in other programming languages, we use includes. And how do we do the same for different files or?
So you can call, so you can like run a file within other file, right? Yeah.
Yes.
So I want to show you. Usually that's what I did in big patches. For example, I'm going to show you an example of that implementation. Just 1 second. There we go. Here. So here I have these 8 patches. For example, in this one, I have syntax, a lot of syntax. So these are just syntax, and these are p-bines. So I use like this. This is my master patch. I've decided the way I call it. This master patch contains all like my GUI and all my MIDI and whatever. So this is the way you call another patch with this one. This method called load relative. This will run another patch that is in the same folder. So if they are in the same folder like this, you just have to put the name of the patch just like this. For example, aldeabombo.sccd like this, and it will run it. But it has to be in the same patch. If you want to call another, you have to use load and you have to give the whole path. It's better just to keep it in the same. So if I run this will run all the stuff that is inside that patch. You can have like, I don't know, ton of syntax and you don't need to have it in your patch. If I run this, it opens me everything at the same time. So it opens me this GUI. This should be working. Yeah.
You also open, when you run this patch, you also open the inputs and outputs server window.
I open this. You mean? Yeah, because I put it that inside here.
Oh, okay, you can control also that.
Yeah, because
Okay.
I just wanted, because basically what this patch worked is that I opened this, and actually this patch was controlled with, so I put my outputs in here. And this actually, for example, you see this, that my GUI has like this weird behavior. It's because my GUI is attached to a MIDI messages. So actually this, I didn't control it with the mouse, I controlled it with my MIDI controller. So when I show you MIDI, I can show you how to do that. So it was pretty cool because I just run the patch and I control everything with my MIDI controller, and I don't have to touch the screen. Actually, this, for example, this one doesn't make sound because, as you can see, they are outputting to different channels. You see? Because this actually was like a 4-channel configuration that goes through 4 headphones to a percussion ensemble. So each one of the interpreters has his own headphones. And basically what they were hearing was P-Vines imitating their instrument. So the guy with the bass drum, like the bomb, I don't know how to call this in English, the Gran Casa, the really big drum, it was hearing that sounds. The guy with the snare was hearing the snares. The guy with the cymbals was hearing cymbals, and so on. So basically they had to imitate or improvise with what they were hearing. So the idea for me was to control the ensemble using my MIDI controller. So because I know that I can send things that were more stable, or because I was sending algorithmic sound and I was controlling like the whole system with like that. It was pretty cool because you feel like you were playing the ensemble. And also it was pretty cool because they were not playing in ensemble. They were playing with their electronic ghosts, and just for the audience, they were hearing the ensemble playing together. So that was like the idea. But yeah, so it was this idea that I had, that I want to have electronics that weren't heard by the audience and something. So, but yeah, so this is a way to have like this master patch. So you just have like this patch instead of having a gigantic patch that has, because these patches were pretty big, as you can see. So in that way, you organize your stuff and you don't have to. So I'm gonna copy what's important. This. Our patch, right? This is our class. Yeah, I'm gonna copy this here. Cool. So yeah, is there any other question? Cool. So yeah, so normally that's what I like to do, at least for, like live performance patches. You make a really cool GUI, and then you can control the whole GUI through the MIDI controller, because usually GUIs are not that cool because you can't, for example, you can't control two faders at the same time. And with MIDI, you can do that, no? And it's cool that everything that you do in your controller, it's outputted in the GUI in the screen. I like that. So now I have these 3 things. So cool. So now I'm going to add here stuff to control the amplitude of the frequency, right? For that, I will use node. Because just to show you node behaves in the exactly same way as slider. The only difference is that it looks different. So let me show you. Here's my node. Obviously, I put it in an awful place. Interesting. I didn't put the rect and it worked. I have never done this. I didn't know that you can do this. You can avoid the rect, but it's better to have the rect. So left, it's okay like that. I'm gonna put it a little smaller. Yes, 120 and 80. No, that was too much. 25. Yeah, that's what I wanted to be in. Yeah. So now I want this knob to control the volume of this frequency, right? So that's cool. I'm gonna call this A, B, C, D, E, F. And I can copy this. F here. and control amplitude number 1 and change this to, actually, I don't have to do anything in the weight because I can leave the value by itself because, you know, it outputs numbers from 0 to 1 and amplitude behave that way. So that would be cool. I have to close this and this and this and this and this and this. Run this again. But now I can control that. So I just need to copy this. F, E, H, 3, 2, 95, no, 100, 110, 105 is actually a good number. There we go. So these are, what's that? 30 numbers. So that would be 135. This, there we go. So So now I can control the three amplitudes and the 3 frequencies with my GUI. And as you can see, I can put the elements in whatever place I want, so I can really customize this. So yeah. So now what I don't like is that when I get ring off, these buttons, well, these are left off in the place I leave it and it looks pretty bad. So what I want is that when I get my ringy off, I want all these to reset to the original values. So how I do that? So I need to go to my button, and when I perform the X3, I need to do this. Because inside this action, I can perform whatever I want. So I can go, for example, C dot value equal to 0. If I run this, see? So now it got back. So now I can do this C. Wait, oh my God. So C, D, E, F, G, and H. And that's what it was important to they have their own variable, right? So like, so this should work now. And they all go back to the original moments. So if I wanted, for example, to go back to 0.5, for example. And it didn't work because I didn't run the code. So if I run this like this, you see, they go to the half of the place. So this is pretty cool because you have like a reset action that controls everything. So up to this point, is there any question? Cool. So I'm gonna show. I think I don't know. Last class, did I show you a GUI? No.
Yes, I think so.
Yeah, just to show you like a GUI that's, yeah, I have this patch that has GUI that just I want to show you. This one where I think is working. Let's see. Yeah. So I have here a GUI. So you can see, you can go pretty crazy with this. So here I'm controlling a bunch of things. I have like this that controls the spectral stuff of my input. I have reverb, distortion, modulation, samplers, loopers, freezes. Here, this is a vocoder. So this one is following the input and making synthesis out of it. It's not about the patch, but about that you can have like these pop-up windows. You can have these numbers that are modifiable by itself. Knobs, delays, yeah. Basically, that's all I'm using. Buttons, sliders, knobs, yeah, pop-up windows, the numbers, and well, and these boxes that are just names, right? Yeah, and also this one, yeah, okay, this do a lot of things, but this is just takes a spectral photography of what's happening. For example, if I'm making, it's with the microphone, no? If I'm making noise, and if I'm making a tone, ooh. So it's cool. Because this patch is intended to work with a live input, and well, it was, well, some guy bought the patch from me, and it was for spectral processes and that stuff. So that, it's a gigantic patch, as you can see, it has a lot of stuff. But basically, what I was trying to show you is that GUI can be pretty useful in that matter.
Can you just show quickly what's the commands to you know, to have like the drop down and to manually input the value that you just showed?
Which
You
one?
know, like to have the, so you are using like two things that we didn't see, like the drop down and
yeah.
also like just to directly, you know, input the value.
Yeah, the numbers.
Yeah, the numbers, and yeah. So
yeah, of course. Yeah. I'm just okay. I'm gonna close this. And this is the class from today. So I'm gonna save this, save as. This is class number 4. Well, we're in June now, but I'm gonna put May just to know which group we are. Sorry, because I have a group that started in May, so I'm gonna get confused. So where is, now I can't see you. Why I can't see the participants? I closed that window. I don't want to close it. Sorry. Well, I don't know what happened to that. That's how life is. Okay. So yeah. Yeah, pop-up menu. It's called pop-up menu. Yeah, of course. Pop-up menu. I'm gonna put pop-up menu, new, W. I'm gonna put 20. Right. Now left will be like 220 with 120. Let's see if this works. Cool, I have it there. Obviously, it doesn't do anything now. So for this, I need to put it. Okay, so I'm gonna put E equals pop-up menu, and I can add E dot items. There you go, and it asks for an array. So I want to put, I don't know, Quito, 1. The second one will be doggy. The last one will be hello. Can put as much as I want, of course. I run this and I got taquito, doggy, and hello. And the action behaves basically the same way. I can copy the action from the button because if you think it, this is a multi-state button, just display in a different way. So when I here, I just can go through here, put whatever, right? So now when I go to doggy, I will get top post line, hello tree, and taquito will get cat. Obviously, I can put whatever instruction I want here. I can put one instruction for my ringy. The problem with ringy is the ringy doesn't have more arguments, but I can create another one. Yeah, this first scale. So first scale, it will be this control basically the octave, right? First scale equal to 1. And run this and change this into x dot set first scale 1. And so I can change octave with this like this. So this will be an octave up and an octave lower. So see, now I control whichever I want with the pop-up menu, right? And the number box behaves the same way, I think. I don't remember the name of the number box, but it should be number box, right? Number, there we go, number box. Number box. Dot new parent. Yeah, correct. Wait. Correct. There we go. I have my number box. I can type whichever number I want. And for the action of this, I have to put, so I want to put Hij equals this. And for this, I can get this action running. So for example, if I would put here this, so slide dot value dot post line. Business posting Yeah. Focus. Sorry. And there you go. It's posting the value, right? It's pretty cool because I can just put my mouse and control it, like scroll it down, or I can manually put whichever I want. And the action will be the same. I want this to be action slide value post time, for example. I don't know. A global variable value be equal to that. I can run, then I can do this, for example, 35. And if I evaluate value, I got 35. If I change this, same. So if some object had this value inside that was controlling something, I will be able to change this in real time, whatever. I can change directly an argument. Yeah. Is there any question regarding these two objects, number box and this? This is basically the reason I'm not even go like go fast to this is because pop-up menu is basically a multi-state button in a different type of display. The difference is that in the multi-state button, you have to go to the states in order. And with the pop-up menu, you can go to whichever state you want. And this is basically a slider because it outputs number in real time like this, It's a slider that works differently. So, cool. Is there any question?
Michelle?
Yeah, tell me.
Is there any way to control any parameter or something with the mouse position, like XY axis kind of slider?
With the mouse?
Yes.
Yeah, you mean something like this? Maybe I haven't showed you this, but for example, I'm gonna build. I'm gonna use the mouse to build how you call this, the
Chaos path.
no, they are the number. It's an instrument. This instrument, it's a theremin.
Terminal.
Yeah, so I'm gonna put frec variable equal to frec. So frec is equal to this object that is called mouse x, and mouse. Actually, you can use mouse X, my Y, and mouse button or mouse push. I don't know, mouse click. So it asks for the min val, the max val. So I have to. So it will be this one. So I want to go from 200 up to 3000. Warp is the curve. One is the one. If I put one is exponential. So I can put here sine osc dot frec phase 0.2. If I run this, and to make it a real theremin, I need to be able to control also amplitude, right? So in the other axis, I will put going from 0 up to 1. And here I'm gonna put amp. And now this is a theremin, right? In a place where I put, now, of course, this has to be control rate because mouse doesn't output signal. So I have volume and frequency, right? Pretty straightforward. I usually just use this mouse and X for two things. One for these demonstrational purposes. Or for example, if I don't fully understand an object, I usually put a mouse X into one of its arguments so I can like move it dynamically and start to understand it. The reason I do, usually musically is kind of annoying to control something with the mouse because if you want to navigate through the screen, then it will change the values. But it's pretty cool. Just if you're gonna use the mouse for that, it's cool. Also, usually I bought this, and this MIDI controller has like its own X/Y axis, so it's like a mouse itself, and this is cool because it's independent from the mouse. So yeah, but yeah, that was basically the way to do that.
And how do you input like a a little square in the GUI to do that, to be like that.
Okay, to be like that in the GUI, it has to be. I haven't done that,
Mhm.
but I don't know. Let's go. Yeah, let's do it. I like that. So let's call this. Let's go to views. View that drag both a SQL drag and drop source receiver. For example, this is pretty cool. A simple drag source, envelope view. Image null level indicator. Number box. Range slider, image. Okay, let's go. I think this one should, let's say this one. No, this one, no. Envelope view. This I have used it, but I want to go to the, I think there's an example in here. Where is the example? There. So I'm going to copy it. Oh my God, this is pretty cool. I'm going to copy the first example, so I'm going to play with it. I'm going to run this. Okay, this is not what I wanted, but it's pretty cool. Doesn't work. That's weird. Okay. Okay. Good. So now the first point will be movable. There we go. As you can see, this is outputting an array of data. So, okay, this is not what you were asking for, but it's pretty cool. So I'm not sure how to make what you ask, but I'm gonna make it in the week and I'm gonna show you next class. Because the reason I'm gonna do that is because I don't know if I'm gonna solve it in 5 minutes and I'm gonna be an hour trying it. So this is how, so, but yeah, I really like the idea and it will be pretty cool because it will only work in the inside the movie. So you can call like a mouse, but only inside that. That will also be really cool, you know, to make spatialization, for example, to move a sound in space. That will be pretty cool.
Yeah, thank you.
Yeah. Also, I'm not yet, but I want to someday. I want to implement. I want to use like a Xbox controller or something to move in processing an object in a 3D environment, and that's sending OSC, so I can move as something in binaural or something like that. But for now, I will solve that you were asking. Yeah. Also, the reason I didn't, I'm not really good at GUI is because I really quickly I moved to MIDI, and also I started using things like this. I don't know if you know this. It's a Wiimote. And this Wiimote, I can show you this. This should be working. Let's see if it's working. I'm gonna share my screen first to show the process, and then my. So this sends Bluetooth. So I'm using this app called OSC Oscillator or OSCulator. I have this. Let me find this. So I need to. how to. Hmm. Okay, wait me a second because I don't remember. Wiimote, para Wiimote. Maybe I have my Bluetooth is not. Uh, sorry, I'm trying to. Mhm. No, this is not working. Why isn't working? It's to be this address. If I turn the Bluetooth off and then I get it on. Hmm. Hmm. What's the code in this? It's asking me for something a little weird. Usually it just connects by itself. Just work with Western. Give me a second. I'm not sure why it's not working, but maybe I just have to go through this. Actually, my Bluetooth gets great.